Hi folks, welcome to lecture 3. In this lecture we're going to take a look at the second part of logs, the laws of logarithms. So we covered these in semester 2, but just to give you a quick review. The log of a plus log of b, if we're adding two log terms, it's the same as if we multiplied the a and b parts. Similarly, if we're subtracting two log terms, we can divide the a and b parts. Third rule, if we have a number in front of a log, it can be brought up as a power. So these are the ones we examined in detail. Note really guys, the main property here, and it's the way the rule I've written them here, is in rule 1 and rule 2 we go from having two logs into one log. Two logs into one log. So we use these rules to compress log terms. If we have several log terms, in order to really do any maths, we need to compress them together until they become a single log term. So this is our main learning outcome of this lecture. We use rule 3 to clean up any logs. If there's a number in front of your logs, we use rule 3 to move that number up as a power. And that's a summary of what we have already practiced. Now there's two other rules, just the log of 1 is 0. Really, we could write that. And I won't get into it. And similarly then, this is what we're saying as well, is the log a of a. These will cancel each other out and we get 1. Because that would be a to the power of 1. They all cancel each other out and that leaves us there. The log of 1 really, where we'd get to there, is 1 could be written as 10 to the power of 0. Then when they cancel out, we're left with 0. We're kind of familiar with these rules intuitively, but I just said I'd include them for completeness sake. So first we're just going to do a couple of examples. Given the log of 5 is this value, the log of 2 is this value. Use the law of logs to evaluate the following. Well, the log of 10, guys, could be written as the log of 5 by 2, which is then using rule 1, this becomes the log of 5 plus the log of 2. Log of a by b is equal to the log of a plus b, plus the log of b, sorry. We know the values for each of these. So the log of 10 is actually, these add together to give us 1. And again, if we wrote that as a power, 10 to the power of 1, we could see that that statement is true. So the answer there, the log of 10 is actually equal to 1. The log of 25, now there's a few ways we could say it's the log of 5 by 5, but I'm going to use the square rule. I'm going to say, well, it's the log of 5 to be squared. Now using rule 3, we're going against the rules and we're going in the opposite direction. I'm going to bring the power down. So that's 2 times the log of 5. The log of 5 is 0.699. And we just get our calculator. And that gives us 1.398. The log of 2.5, we'll take a look at that. I know it's 0.398, but I'll just show you, I'll prove it. So how we could do this is just using division. We could say, well, the log of 2.5 is actually the log of 5 divided by 2. So using rule 2, this becomes the log of 5 minus the log of 2, which is 0.699 minus 0.301, which is 0.398. And remember here, guys, 25 was 1.398. If we wanted to find the log of 250, that's actually going to be 2.398. The log of 2,500 is going to be 3.398. Now, we weren't asked for them, but it's just there's a very solid pattern to logs as well. Similar problem, the log of 12, well, this could be using rule 1. This is the log of 3, I'll do it in the order they're written, 4 by 3. So using rule 1, log of 4 plus the log of 3. 0.6021 plus 0.4771. Just use your calculator. I'm just checking I haven't made any errors. So this gives us 1.0792. The log of 48, well, that could be written as the log of 4 by 12, which we did in the previous one, but we'll just keep, we could do it this way. So now this just becomes the log of 4 plus the log of 4 plus the log of 3. 6021 plus 0.4771. Get the calculator. And we get 1.6813. So don't use your calculators for these, guys. There's slight rounding errors because we've already rounded these logs. So in the journal, guys, I need to see it written out like this. Not just you keep writing out the answer. I need for you to demonstrate you understand what's required. Last one, log of 0.75. Well, that's the log of 3 over 4. Using rule 2, that's the log of 3 minus the log of 4. 0.4771 minus 0.6021. Our answer is going to be negative, but that's because we're looking for a value between less than 1. The log of any value between 0 and 1 is always going to be negative. And that gives us minus 1/8, which is minus 0.1250 in this case. So there's our answer there. So that's just kind of an introductory kind of example of using the log laws. So now, given the log of 2 is 0.301, evaluate the log of 2000. Well, the log of 2000 is actually the log of 2 multiplied by 1,000. And now we can use our log laws. So that's equal to the log of 2 plus the log of 1,000 Again, I'll just write 1,000 though as 10 to the power of 3. The log of 2 is 0.301. Now remember, that's log to the base 10, they cancel out. So the log of 1,000 is actually just 3. So that's the log of 2,000. The log of 200 would be 2.301. The log of 20,000 would be 4.301. Find the log of 0.2. Well, that's the log of 2 divided by 10. Be careful with these ones, they're not as intuitive. So this is going to be the log of 2 minus the log of 10. Remember the log of 10, 10 to the power of 1. So this is going to give me 0.301 minus the log of 10 is actually just 1. Now again, guys, I'm looking for the log of a value between 0 and 1. I expect my answer to be minus, and it is. It's minus 0.699. Part 3. Evaluate 10 to the power of 2.301. So this now, 10 to the power, this just requires a little bit of different thought. That's actually, remember, it's 10 to the power of 0. Multiplied by 10 to the power of 2. Just using our rules of powers from our first lecture, exponents. And now 10 to the power of 0.301, well, that's equal to 2. And this is equal to 100. So my answer then is 200. And again, guys, I need to kind of show this kind of working out. So that's the first type, just working with numbers, just getting used to using the logs. And now we're going to use that compressive property that logs have. So we'll be kind of working the other way. We'll be going from log A plus log B and bringing it to, so we're going to compress 2 log terms into 1. Now the reason why we need to do this, guys, is because simply say if this was a number here, we can't solve this problem as it is. With 3 logs, guys, you cannot use 10 to the power of to kill the logs. It doesn't work like that at all. If we got 10 to the power of both sides, just to quickly show you, what we would now have would be 10 to the power of all of this is equal to 10 to the power of 3. And now you're in a dead end because you've logs and 10 to the power of in the same expression. You're never going to find a way out. So what we have to do is compress all of this until it's a single log term, and then we can solve it out, which we'll be doing in a later slide. So at the moment we don't have a value. We're just looking at the compressive style of logs. So first thing, guys, if you remember what I was saying is we'd like to use rule 1 and rule 2 first, but we've these numbers here. So we need to clean up the logs first. We need to move those using rule 3. And what we do is using rule 3. Now note how I put brackets around the 3x. So the 2 is going to come up to there and that 2 is going to come up to there. Plus the log of 2x to be squared minus the log of x. And finally, guys, remember, if you're squaring a term, both bits get squared. So now the 3 gets squared, which gives us 9, and the x squared. This 2 gets squared, as does the x. So 2 gets squared, x gets squared, minus log x. So now we've kind of, at least we've nice clean logs, as in there's no numbers in front of them. Just double checking I haven't made any mistakes. I don't think so. Now we're going to use rule 1 on these two bits. So rule 1, log of A plus log of B becomes the log of A by B. And this guy is still just waiting outside. And now numbers do what numbers do. 9 by 4 is 36. X squared by x squared is x to the power of 4. We have minus the log of x. So using rule 2 now, because of the subtraction, log of A minus the log of B is the log of A divided by the log of B. So this will give us 36. If you want, you can write a 1 in there, guys. So numbers do what numbers do. 36 divided by 1 is 36. X to the power of 4 divided by x to the power of 1 is x cubed. What's very important to understand, guys, then is that these are equivalent. So this value and this value are actually the same. They're saying the same thing. In the exact same way as 4,000 over 8,000 is the same as a half. They look completely different, but they're equivalent. This value and this are also equivalent in the same way. Now you guys have a go at the next one, so when it appears. So just give this one a go. Pause the video and see how you go yourself, and then I'll talk us through it. So hopefully you've had a go. I'm going to clean up my logs first. Remember to put brackets around these before you move up the power. Minus the log of x squared to b squared. Don't take big jumps, guys. I know you might think you're saving time, but you're not. If you're kind of trying to skip steps, you're going to make a mistake. This is unchanged. Using the rules of powers. And now 2 cubed, guys, is not 6. 2 by 2 by 2 is 8. Now, I'm just going to rewrite these, guys. You don't need to do this, but I'm just emphasizing a point. So I've just literally moved the negative term to the end because now I can use rule 1 here. I always like to use rule 1 first, regardless. Just makes life easier in the long run. So this becomes 4x by 8x cubed. So just this bit becomes the log of 32. Just double checking I'm x to the power of 4. And now this is waiting here for his turn. And now using rule 2, the log of 32, x to the power of 4, divided by x to the power of 4. You can write a little 1 in there. And that just simply gives us the log of 32. The x to the power of 4s will cancel out because they've got the same power. So again, guys, this expression and this expression are equivalent. Even though they don't look anywhere near the same, they are actually the same. Now, same idea, guys, but we now have a value. We now have an equation, whereas in the previous slides we had an expression. Expressions can have equal signs, but we're now specifically dealing with an equation because we have our equal sign. So sorry, expressions, it's like a family, guys. This is the big family of expressions. Any mathematical statement with variables is an expression. Within them is an equation, but an equation must have an equal sign. So an equation is technically an expression, but it's a particular type of one. So now, there's no numbers. Oh, there is a number in front, sorry. The 2 there, sorry. First value is unchanged, ln of 2x cubed. Now I'm going to bring the x up, x squared, so he goes up, again put brackets. And that's equal to 2.4. The 2.4 isn't going to have a role to play until the very end. Using rule 2, subtracting 2 terms, they divide. And now numbers do what numbers do. This becomes the natural log. 2 divided by 1 is 2. X cubed divided by x squared is just x. And now we're into more familiar territory, like what we were looking at in the previous lecture. We want to kill the natural log, so we get e. We raise both sides as a power on e. That knocks out the natural log on the left. And we get e to the power of 2.4. And finally, divide both sides by 2. And we get x is e to the power of 2.4 divided by 2. And then it's just a calculator exercise. E to the power of 2.4. Be careful to move your cursor out that you don't put in e to the power of 2.4 divided by 2, which would just be e to the power of 2.1, which is a different thing. So it's kind of this on your calculator in brackets divided by 2. And we get 5.5115, blah, blah, blah. So on the journals, guys, I don't really mind. As long as you have a couple of decimal places and you've done everything correctly, you're going to get the marks. I'm really just interested in this bit. You know, your answer is just more of a calculator kind of a button pushing exercise. In the journals as well, guys, I'd like to see, well, I'll be marking you, I'll be expecting you to lay out your problem similarly to this. Do not just write an answer, you won't get any marks. And neatly, guys, try and be a bit neater than I am, but I'm kind of, speed is of the essence at the moment for me. So have a go at this one now. Again, pause the video, get a bit of paper, give it a go. The natural log, so I'm going to use rule 3. Bringing up this power. Remember always, guys, to put brackets here. It's so important. Minus 2, oh, sorry. Obviously, that's moving up as a power. Natural log of 2x to the power, 2x to be squared, all to the power of 2, and that's equal to 0.25. So in this step, guys, I'm just using rule 3 to clean up my logs. Natural log of x. Now again, be careful. 2 by 3, we multiply. Here, guys, both terms get squared. 2 squared is 4. X squared to b squared is x to the power of 4. And now using rule 2, we divide our logs. So it's x to the power of 6. Divided by 4x to the power of 4, and that's equal to 0.25. Numbers do what numbers do, so natural log is natural log of 1/4 x squared. And again, you could write that as 0.25 instead of the quarter, but we'll just keep things going. It's a bit odd having the fraction and the decimal in the same line, but we don't, it doesn't matter. We're still just working things out. So we've reduced our term to a single log term, and now we're going to solve out. So raise both sides as a power on e. Quarter x squared is e to the power of 0.25. Want to get rid of the quarter, guys? I could divide by a quarter. But really remember, dividing by a fraction is the same as multiplying by its reciprocal. Flip it upside down. So I'm just going to multiply both sides by 4. And now I want to get the square root of both sides. So we get x is equal to the square root of 4e to the power of 0.25. Few ways I could work that out using powers, but because I've got a calculator, I'm just going to keep moving. Square root of 4e to the power of 0.25. And that gives me 2.2663, just if we want to go to that level. So I hope these make sense, guys. It's just, again, it's a very important skill, especially once we move into the next week when we start analyzing log plots and stuff like that. We're going to need these skills with us. That's an E there, just to be clear as well. Here's another one. Again, you guys give it a go. These ones, they're kind of getting progressively harder, but it's just you have a similar bunch on your journal, so we just work through them. Using rule 1, guys, there's no numbers, so we don't have to use rule 3. We don't have to clean anything up. So there's us using rule 1. Log of a plus log of b is equal to the log of a by b. Multiply out our brackets. Now, raise both sides. We want to solve now because we've reduced it to a single log term. Raise both sides as a power on 10. X squared plus 3x is equal to 10 to the power of 1. And now sometimes you'd be scratching your head, kind of go, okay, what do I do from here? There's not a single x term. It's simply a quadratic, guys. So we bring the 10 over. And now we use, you could use the quadratic formula, but just be very careful, guys. It's very easy to make a mistake. I'm just going to factorize. I'm going to do it quickly, guys, because I kind of have, so we have 5 and 2. The reason why I'm picking 5 and 2, because the difference between them is 3. 3x is positive, so my biggest value must be positive. My smallest value is negative. So those are our factors. And again, guys, you're going to have to kind of work on that a little bit more. This is my job. I'm used to doing these. I hope I haven't made a mistake. I don't think I have. And now we let each factor equal to 0. So x is equal to 2 is one solution. And x is equal to -5 is the other solution. Thinking back though, remember our log graph. There's no such thing, you can't get the log of a negative number. So for that reason, guys, I'm looking back up at this equation. Here we have the log of x. So if I put -5 in there, that just doesn't, you've got a syntax error, you cannot compute it. And similarly, if I put -5 in there, again, I'm getting the log of a negative number, which is impossible. Logs don't exist in the negative realm. So for that reason, guys, this answer here is actually invalid. So x is equal to 2 is the correct answer there. More fun. Again, give them a go. Pause the video. Log of x plus 2 by the log of x minus 2 is equal to 2. Now I know this, guys, this is the difference of two squares, but even if you multiply it out using FOIL, I'll do that just to kind of make do to be a bit. So we're going to get first terms, x by x is x squared. Outer terms, minus 2x. The inner terms, 2 by x is plus 2x. And then the last terms gives us minus 4. Now when we tidy this up, these cancel each other out, and we get the log of x squared minus 4 is equal to 2. Now we want to solve for x. So raise both sides as a power on 10. That kills the log on the left. So x squared minus 4 is 100. Move the 4 across to the number side. X squared is 104. So x then is the square root of 104, which is obviously going to be 10 point something. Let's get the calculator. So pretty much 10.2. And again, pause the video and have a wee go with this one. This is a lot of people don't like these ones. This one requires a bit of work, so I'll try and write a little bit smaller, guys, because I'm conscious this one's going to take a bit of going. First of all, using rule 1, we're going to get the natural log of 2x plus 1 been multiplied by 2 over x, and that's equal to minus 1. Now remember with fractions, so it's kind of top by top, bottom by bottom. So that's going to give me 2x, sorry, when I multiply the top line by 2, I'm going to get 4x plus 2, all divided by x. So just put brackets around there. I hope that makes sense. Top line, guys, 2x plus 1 by 2, 1 by x on the bottom. Now I'm going to get rid of my natural log, raise both sides as a power on e. So on the right hand side, we're going to get e to the power of minus 1. On the left hand side, when we raise natural log to the power of e, it cancels out. And now, this is tricky, guys, because you've kind of got two x's on the left, and it's a little bit like formula manipulation. We have to double trouble. We have to bring this back to a single x term. So first of all, I'm just going to compute e to the power of minus 1. That's minus, sorry, it's not minus, it's 0.368, we'll say, with a little bit of rounding. And what I'm going to do, guys, is first of all, that's it computed. And now I'm going to multiply, no, I'll keep it, so 4x plus 2, so I don't wreck any heads. Now I'm going to multiply both sides by x. So to bring this x up, we'll get 4x plus 2 is equal to 0.368x. And now I want to gather all the x terms together. So I'm going to subtract minus 0.368x from both sides. And at the same time, guys, I'm going to bring the 2 over to the other side. So I'm going to subtract 2 from both sides. So essentially, he's going to move over to the left and he's going to move over to the right. So we're going to get 4x minus 0.368x is equal to minus 2. This is going to give me 3.632x is equal to -2. And now we're nearly there. We can divide both sides by 0.362. So we get x is equal to -2 over 0.362. Our answer is obviously going to be negative. Oh, sorry, hang on. I'm making a mistake here. Sorry. I'm sure you spotted it. I'm dividing by 3.632. Yeah. So, like I said, my answer is going to be negative. And we get and that gives us minus 0.55. And we just leave it at that. There's a few more decimal places there, but nothing significant. And that's our answer there. So again, guys, in the journals, I really need to see kind of a neat progression. So write it out in rough first and then write it out neatly on an A4 page. And once you have them all complete, scan it in and upload it to Moodle. So we're nearly there now, guys. We're kind of this is a new topic. It's using the rules again, but we didn't do this last year. Expand and simplify the expression here. So here, guys, it's really, we've got log of A by B. So we're just actually reversing the process we've just done. So using rule 1, that becomes the log of x squared plus the log of y squared. And then using rule 3, we bring the powers down. So now we've expanded and simplified, and that's our new expression. And again, guys, these expressions, they're equivalent. They're both the same. It's just different ways of writing them. Similarly, again, you guys give it a go. Expand and simplify this expression. I don't think I have this one written out, no. So using rule 2, guys, this is going to become, the natural log of x squared plus 1 minus the natural log of e to the power of x. Not much else to do. The natural log of x squared plus 1. And here, guys, minus the natural log of e. They're inverse functions. And then we get this. So I hope that makes sense. We won't come across these ones too much, but it's just to kind of make sure you can go both ways. You can go both from a compressive function. You can go from a compressed function into an expanded function, or like we did in the previous slides, go from an expanded function into a compressed function. So all we're doing here, guys, is really just getting you familiar with the log rules, all the skills involved. And now next week, we're going to bring these skills to bear when we start analyzing log plots and things like that. So thank you for your patience and thank you for listening, and we shall chat to you in the next lecture. Oops.